I've been in the Bitcoin space for about 5.5 years. I'd known about it before then, but I never actually did the deep dive until like 5.5 years ago. And at the time, Bitcoin was trading between the 200 and 300 range, and it's hovering around the 16,000 range right now. So it's come quite a way since first getting into it. So some things I'm going to do just today, some topics. Cover a brief history of Bitcoin, some terminology, how Bitcoin works, why we need it, how to acquire it, and then give some context to why the price is going up, and some models that I think are why it's gone up. And I put in the disclaimer, not financial advice, because the one that did these models is anonymous, and he did that so that you would do your own research. So Bitcoin is a culmination of actually decades of work. It wasn't just something that appeared out of thin air in 2009, January 2009. There were a lot of people in the cypherpunk movement for decades were trying to solve a bunch of problems with how you make a secure digital form of money. A couple of them in the 90s, David Chaum was a cryptographer, and most of these people were cryptographers doing this kind of stuff. But DigiCash was an early one. That was probably the one that almost made it in the 90s, but never actually got out. BitGold, RPow, BMoney, and Hashcash were some other implementations. And each one of these successful ones or successive ones solved a different problem with having a digital form of money, because with central banks, you have to have a trusted third party. So you have banks that hold the money, and if I want to send money to your bank account, we have the banks in the middle that have the trusted third party, and they do that. Well, if you're on the internet, you really can't do that because you have people that you don't know, and you have to have a way to settle that. So what Bitcoin did was it solved two things, and I used another current events thing. We've been playing a lot of Among Us, so consensus is what Bitcoin did solve with this, and it did it with the Byzantine generals problem. So if you've been in computing, you've probably heard this, but basically there's a city under attack, and there's 5 armies that are around the city. Well, all 5 of the armies are in different locations, but in order to take the city, you have to have consensus between the armies to attack the city. You have to also assume that there are going to be some army generals that have malicious intent, and if everyone says they're going to attack, but then some generals do not attack, those armies that attack will die. So you have to have this untrusted third party that you all have consensus with, and Bitcoin solved that, solved the Byzantine generals problem. It also solves what's called the double spend problem. And the double spend problem is basically John has $10, he sends Alice $10 and Jack $10 at the same time for a specific gift. Well, if you have a zero balance, the bank will, basically the problem is the bank will reject them. Alice and Jack send both gifts to John, neither of them get paid. So the same thing happens in Bitcoin. So if you send transactions to two different people, I'll go through the stuff later how it does this, but it solves for that, and so you can't double spend your money. So you can only spend the balance that you have, and it's settled through an untrusted third party. Again, because you do not have the banks, and the banks have been the central clearinghouse and only allow a solution at a time. And what does that is called proof of work. And I'll get into that too when we go into mining, but it solves that order of transactions. So before I get into more of the technical stuff, I was going to go over some terminology just so kind of a good understanding of what I'm going to talk about. So when I talk about transactions are just peer-to-peer transfers of information. With Bitcoin, you can sign messages in your transaction and stuff like that, but it's in Bitcoin terms, you're sending Bitcoin from one person to another person, or as we say in address, you're sending it to a different address. Blocks are just groups of transactions, and they go into, I'm skipping one, but they go into the mempool. So basically, or transactions go into the mempool, I'm sorry. So if I say, I'm going to send Casti 5 Bitcoin, we sign that, send it out into the ethos, and it goes into the mempool. And from there, then the miners can pick transactions to put in blocks. Each one of those transactions will have a transaction fee, and that's an incentive for the miners to include that transaction in a block because there's thousands of transactions going on all the time, and you can only have so many transactions in a block. So what's a miner? So a miner is just a computer that's trying to validate the transactions in the block because there's certain rules that they have to follow in order for a transaction to be valid. Because again, you have to have an untrusted third party and everybody plays by the same rules. So proof of work is computational work, and we'll get into some of that a little bit later too. But it's basically finding or putting in the work to validate transactions that everybody says, yes, that is correct. A block reward is a reward. So it's just like the transaction fee. It's an incentive to the miners to try and find blocks. And that also secures the network because you want the miners to do the right thing and do these. And this is an incentive, a monetary incentive to confirm transactions in blocks. In the Merkle root, every transaction is a hash. In the Merkle root, if in computer science, you can have a lot of information in a single hash, and Merkle root is in the header of every block, and it's all the transactions that are in that specific block. So to go into a little history of Bitcoin, I've got some just different significant dates in here. So August 18th of 2008 was when Bitcoin.org was registered. And in 2008 was a financial crash. So Lehman Brothers went bankrupt September 15th. And about a month and a half later, there was a letter that, or a white paper that went out. It was called Bitcoin, a peer-to-peer electronic cash system, by someone named Satoshi Nakamoto, who we still do not know who it is. And it was a 4-page paper that described this new form of money. And Satoshi had actually already written the code and was describing what they had already written. A little over 2 months later, the Genesis block was mined and the network is live, and it has never been down since it went live on January 3rd, 2009. And it started with a 50 Bitcoin reward, and we'll go into a little bit why that's important later. That's the incentive that I talked about in the last slide to do different things. About 9 days later, Hal Finney received the first Bitcoin transaction from Satoshi, and Hal passed away about 5 years ago from ALS, but most people think that he actually was Satoshi because it was about when he died when Satoshi quit posting on message boards on the internet. So a couple other things, 10,000 Bitcoin. I'm sure everyone's heard the urban legend about 10,000 Bitcoin used to buy $25 worth of pizza. That's worth hundreds of millions of dollars now. So they're pretty good pizzas. Silk Road was another one early on that used Bitcoin as a form of anonymous payment. It is sort of anonymous, but not completely. And then March and April of 2011 was when Bitcoin passed the $1 threshold. So a couple other dates. In 2013, it skyrocketed, and it was the first big jump after it passed the dollar. So if you see in February of 2013, it was $30, and in November, it topped $1,200. So that's quite an increase in just a single year. There were a couple other things that happened. Mt. Gox lost about 850,000 Bitcoin, which I'll go into later. You never want to keep, and that's an exchange. You don't want to keep your Bitcoin on exchanges because you don't actually own it. And then about 3 years ago, Bitcoin hit its highest price ever, almost 20,000, and we're getting close to that again. And the most significant thing for the financial stuff I'll go through is the halving. So about every 4 years, that block reward gets cut in half. So it started at 50, it went down to 25, and then 12.5, and now it's 6.25. So what are transactions? I kind of talked about this, but they're just broadcast to the network. They're included in blocks. And the miners treat transactions with the highest fees preferentially because that's going to give them the most monetary incentive to include them in blocks. And the more blocks mined, where your transaction is, the more secure it is, because I talk about proof of work, you have to exert that same amount of energy to basically rewrite the blocks, because when the blocks go out, the whole network says, okay, yes, this is a valid block, and now I'm going to build on this specific block. And so the blockchain is just a sequential order of blocks that can chain transactions. And each transaction uses the previous, or each block uses the previous hash, and also transactions have an order. And so you can follow transactions and follow Bitcoin back to their origin. And if I'm going through this too fast, or if you have questions, stop me too, because I know it's a lot of information. So mining. So on average, a new block is confirmed about every 10 minutes. And so you have a set amount of blocks that you know come out every day. Blocks have a size of about 1 megabyte, and transactions, depending, they have a variable size limit. When blocks get sent out, the network comes to consensus. And like I said earlier, every block header has hashes of the previous blocks. So there's only about 21 million Bitcoin. Everyone says 21 million, but it's just shy of 21 million Bitcoin that will ever exist, ever. And that's a hard cap. With the halving, though, that amount of new supply goes down over time. So we actually won't have all the Bitcoin in circulation until the year 2140. And based on the block halvings, they go down. So we've mined about 18 million-ish Bitcoin so far. So over the next 100 plus years, we're only going to mine about another 3 million. So simple supply demand. If there's less new being generated, the supply goes down, demand remains the same, price goes up. So the mining process itself is actually pretty simple. They're basically just trying to guess a number. So what happens is there's a thing called difficulty. And so every 2 weeks, the network analyzes how many blocks have been created over the past 2 weeks. If there have been more than the normal every 10 minutes, the difficulty goes up, which basically means it's harder to solve the mathematical formula to mine a block. And so what the miners are actually doing, all they're doing is just putting random numbers into the SHA-256 algorithm, seeing the result and seeing if that number is within the difficulty rating the network has at that time. So basically what the difficulty rating is, and then on the next slide, I'll show you how it goes up over time. They basically have a number, and it's a very large number, but you have to get, when you put your number into that algorithm, you have to get it within that range, and you can mathematically prove it'll take about X amount of time with this specific number. And so the network by itself, every 2 weeks, basically evens the field. So if you have people standing up data centers to mine Bitcoin, every 2 weeks it readjusts so that even if you have more people, the network scales and you get back to about every 10 minutes there's a new block. And that's how we know when all the Bitcoin will be mined, because we have that schedule that self-adjusts. So right now, I did this yesterday, but right now there's about 114 exahashes every second that happen. And that's this many guesses. So 114 and 18 zeros, that's how many guesses per second that miners are running this algorithm to try and guess that number to mine a block. So that's a lot, and that's every second. So this is a chart of the hash rate over time from the very beginning. And as you can see, it's gone up over time. And this is important because this is what secures the network. So we can't just have someone pour $1 billion in computers and be able to take over the network very easily, because there's so many people around the world that are mining Bitcoin. And you can see this is growing exponentially. So, I mean, that's a lot. And this is 24/7, 365. That's how many guesses every second are happening. And there's still, every 10 minutes, one more block that's been mined. For the next one, we look at the difficulty. So I said the network scales over time. So this is the difficulty level for mining. So if you look at these back and forth, you can see that as difficulty and hash rate goes, or as hash rate goes up, so does difficulty. So the network is always going to stay within that 10 minutes for every block. If there's hash power that goes offline, the network makes it easier to find blocks, so that instead of a block every 15 minutes, it goes back down to every 10 minutes. So how does this work? So this is all abstracted away, but I'm going to go through some of the technical stuff for this. So Bitcoin is based on private and public key cryptography, which is asymmetric cryptography. So private keys can be anything between usually 1 and 2 to the 256 power, and they're usually stored as a hex value. So the private key is what unlocks your Bitcoin, and it's what allows you to send Bitcoin to other people. So anyone that has your private key has access to any Bitcoin that private key has access to. So this is something that you want to always keep secret, and you never want to, if someone has this, it's over. But because these are generated randomly, the likelihood of someone guessing it are basically zero. So what happens, you have your private key, and then it goes through using elliptic curve multiplication, which is a trapdoor function. So in cryptography, just like the security on the internet, you've got your public and private keys. It's really easy to multiply one way, but it's really hard if you don't have the inputs. So this curve I'm showing in a 2D way is not actually what it looks like. It's actually, it uses 3 axes, but it looks like random. So how we generate our public key is just take the private key times the generator point, which is using this specific curve. So it's equal and opposite parts on this curve, if you will, that it does this. And so if you change any part of the number, it's completely different. So Bitcoin addresses then are created from taking the SHA-256 of that private key and running it through the RIPE MD160 algorithm, which again is a trapdoor function one way. And then this creates your Bitcoin address. So behind the scenes, this is all happening, and you really only need to see your Bitcoin address, which is what you need to send people money or receive it. A little more behind the scenes stuff. With cryptography, you have signatures, digital signatures, and then ways to verify. So you can verify and you get just a true false from that, and that's how you verify behind the scenes if the person that is sending you Bitcoin actually does have access to the Bitcoin they say they're sending you. Multi-sig addresses are just multiple signatures to spend funds. So as companies, you may need a sign-off from several VPs. They all have their own private keys, and they all have to agree and use their private keys for any Bitcoin to be unlocked. You also have vanity addresses. So most addresses are about a certain length. Vanity addresses are used for like fundraisers or things like that, where you want the first X amount of letters to say a word or something. So in this example, I'm just using one cat's ZZZZZ. So to generate these, like I said, you can put in random numbers into these algorithms and they'll spit out addresses. So what people do is basically just run through addresses and try and guess what these are. So this specific address takes about 1 minute to find, but the more you add to it, the harder it is to actually generate this. So the bottom one, I guess the second one, so there's approximately 58 to 29th power addresses. They're in the range that start with 1 cats. But if you do 1 cat's victory, it would take you about 2.5 million years to guess that address that starts with that. So every single letter you go further, it takes exponentially that much harder to find. So we're talking about transactions. So how do we actually do that? So this is a pretty simple example of transactions. So transactions inputs are used, or transaction outputs are used as inputs going forward. In the next slide, I'll kind of show this more. So Joe sends Alice 5 Bitcoin. So Alice gets that in her wallet, then she sends Bob 5 Bitcoin. That same output that she got from Joe is used as the input then that goes to Bob, and then Bob to Gopesh. So this is an actual example of these. So this is from Andreas Antonopoulos, his book about Bitcoin. But if you look at this output that she received from Joe is this 0.1 Bitcoin. That output then is the input. This number here, this transaction hash, is the input from the output that she got, and so forth. So while this is cool to see, you don't really need to know because the wallet softwares behind the scenes are doing all this. But I think it's just kind of cool to see how all this stuff works. So what are wallets? So wallets are basically application developers have created them to store and keep your balances of the Bitcoin that you own. They can be on computers or phones or anything like that, but they're the primary user interface for these. So what happens is when you say on your phone, you do a new wallet, you will get a seed phrase, which is usually 12 words, that generates randomness to actually generate your private key, because humans are not very good at themselves at randomly guessing words. There's about 2,048 words that this list pulls from, and the randomness helps you create private keys, which then become addresses that are virtually unhackable. The wallets also do not store coins, so the blockchain itself is stored out on all the computers in the world, and it's a public ledger, so everybody can see all the balances that anybody has in any address. But they are just hashes of that, so you don't know who owns them. But the Bitcoin are actually stored out there, so your wallet doesn't actually store your coins. It just has your private keys and a list of any transactions that you have either received or sent. The important thing here is if you lose your private key, they're basically lost forever, because you cannot guess the private keys because of the stuff I talked about earlier. So why do we need Bitcoin in the first place? One, we had in April $2 trillion of air that was printed out of thin air, and that devalues our currency. Bitcoin, on the other hand, is a deflationary currency. So we know the set amount, but as time goes by, we get less and less of it that gets put out into the system. That's why I talked about the block reward. Bitcoin also has intrinsic value. So it has a store value, it has immutable transactions, it has a cap, and it's a medium of exchange. It's also borderless. So with the US dollar, if you want to send money to a relative in Australia or something like that, it's very hard to do that. With Bitcoin, you can do it in a matter of minutes, and it's accepted everywhere that you have internet. It's also censorship resistant, which is good and bad, because like with anything, terrorists can use it, but they're already going to use cash anyway, so that just comes with it. It also hedges against governments devaluing your currencies. So if you followed stuff in Venezuela or Greece or Zimbabwe, you have trillionaires that are homeless because their money just isn't worth anything, because their government's printed so much money that it devalues it. And it's also better than gold. It has all the same values, but it's a lot harder to move $100 million worth of gold across the ocean than it is just to send a Bitcoin transaction in a matter of minutes. So how do you acquire it? It's pretty simple to do. All the stuff behind the scenes I talked about happens, but basically you just join an exchange. There's a bunch of them. Do KYC, which is know your customer, which is just general run-of-the-mill banking industry stuff. You can just buy your Bitcoin there, pay with US dollars or any currency really. Set up a wallet, like I talked about earlier. Let's include generate your seed phrase and all that, and storing that. And do not put it on the internet, because things get hacked. And if someone knows what Bitcoin is and looks and sees, oh, this looks like an address or private key, you might lose your Bitcoin. Then you can just transfer Bitcoin off the exchange to your own private wallet, and you keep it there. You never want to keep your Bitcoin on exchanges, because they are businesses and they are the ones that have the private keys. So even though you have Bitcoin in your account, you actually don't have control over it, because they own the private keys that will actually unlock that. So last thing I want to talk about, and again, this is not financial advice, do your own research, but Bitcoin has, over time, like I've said, gone up tremendously in value. So in March of 2019, Plan B, his Twitter account is at 100 trillion USD, published an article about stock to flow. And stock to flow is a model based on supply and demand. And it's used for gold and several others for how to basically value something if you know how much supply you have. So what the model says, and I said earlier the halvings are important, and the halvings again are the halving of the new Bitcoin that's issued every 10 minutes. We just had the third halving in May of 2020. And because of that, even if we have the same demand, we have less supply that's coming out every 10 minutes. Therefore, just based on simple supply and demand economics, the price will go up. So his first model he put out was a stock to flow model, and it estimated by the end of next year, the price would hit about 55,000 per coin. Based on the history of this, about a year and a half after every halving, the price hit its highest point before the next halving. In April of this year, he released his stock to flow cross asset model, which is a little different than his first one because it took out time as a part of the process of the model. And that one estimates that between now and December of next year, Bitcoin will hit between $100,000 and $288,000 per coin. And this is one of his charts he put up for stock to flow. So every dot is a month close. So the red dots are right after the halving happened, and the blue dots are the closer it gets. So based on his stock to flow models, you can see the dots, and they follow the model pretty closely. Every time it goes up, that's when the halving actually happens, or right after that, I guess, based on the model. So if you look at all the other ones, they look like they're going to go up. So do your own research, but this model is the closest thing I've found to actually predicting what's going to happen. And if you look at the Google Trends for Bitcoin, look at the end of 2017 when the interest went up to 100. That was when Bitcoin hit 19,000 the last time because people were excited, there was FOMO, all that. And now Bitcoin is up in the 16,000 range. And look at the search interest. It's basically nothing. And Bitcoin has risen to where it is with basically no additional interest, which is also, I think, pretty cool. So just to wrap up, kind of went over some of the history of Bitcoin, some terminology, kind of went over the mining process and creating blocks. There's a lot that goes behind the scenes in cryptography for Bitcoin, kind of showed you where to buy it and the theory of it. I could talk about this stuff for hours, but I did basically hit my 30 minutes, so I was pretty happy with that. So thoughts or questions?
I have so many, and I don't know where to begin. So I guess my first question is, should I not be using Coinbase then?
No, you can use it to buy, but I would just not keep your Bitcoin there.
Oh.
I would move it off to a wallet that you actually have the private keys to.
I see.
Yeah.
Have you heard of a platform called Solana?
Mm-hmm.
Solana, I'm putting in there. I'm still like learning about them and stuff, but they're basically like a platform for building your own wallets and everything. And so as you were talking and stuff, I was just like, dang, should I be using that platform to make my own wallet and store stuff? I don't actually know. And that's kind of a question and kind of a comment.
Yeah, I've actually done some Bitcoin development. There's a bunch of different libraries. Most of the best ones are in Python, but there's a really good C# one that I use.
Perfect. No, I was just going to say, are there any kind of tools you recommend, like for managing your wallets and performing transactions?
So the wallet software itself will keep track of all your transactions and stuff. Blockfolio, though, is a good way to keep track of if you have multiple wallets, like different places. Because I have one that I have on my phone that I've got Bitcoin on me all the time, but then I have other wallets that are just for cold storage that I don't plan on doing anything with for like at least another decade. So, but Blockfolio helps a lot with taxes too, because the one thing that sucks about it is every transaction is taxed as property. And so you have capital gains tax that you have to pay. There's no way to enforce it, but if you want to be a good citizen and pay your taxes, it's hard if you have hundreds of transactions. So Blockfolio helps a lot.
This is fascinating. The thing that blows my mind, and you did touch on it, and I wish I got it. The concept of mining blows my mind. I truly don't understand how people get all of these super, super fancy graphics cards to discover a block someday.
So Yeah, so it's not profitable to do mining now, but it started out on CPUs and then moved to GPUs. But now all mining is done on ASICs. They're chips that are specifically built to run the SHA-256 algorithm to just make guesses. I mean, that's literally all they do.
And so like when they're making guesses, are they just like, I assume they're making guesses for like some key thing. How do you know that it's part of how do you know it's a proper block?
So for one, the miners, they basically make candidate blocks. And so they get a bunch of transactions and they form a block and then they start guessing. And so the difficulty is basically find a number between 19 trillion and 20 trillion. And so the SHA-256 algorithm, any number you put in there is going to have a different output. And so all they're literally doing is just plugging in random giant numbers, running that algorithm, and then seeing if that value fits in between 19 and 20 trillion is essentially all they're doing. If it is, then that means their block is valid. They broadcast it out to the network. All the other miners validate it. They say, yes, this is correct. And because everyone has all the previous blocks, the previous block has a hash. So every block has a hash. That hash is then hashed into the new one. And if it mathematically fits, it is a valid block. And then everyone goes, okay, this block is now on the blockchain. Now we're going to mine the next block. So there's a, let me get this.
For other coins like Ethereum, let's just say, is it similar, just a different set of blocks?
Ethereum is a blockchain too. It's a different type. But Ethereum's main thing is allowing you to build decentralized applications on top of the blockchain.
I see.
So this is a really cool website so there's blockchain explorers. So that Blockfolio or Blockchair website has different statistics on mining and the blocks. So we are on currently 656,947th block of the Bitcoin blockchain. So you can search for any Bitcoin address, any transaction hash, and you'll see the actual transaction, when it happened, when it was confirmed. And again, this is all public information. It just hashes, so you don't actually know. It's not like this is Josh's account, you know. So,
right.
But all the like address amounts are public, and
it's pseudo-anonymous as opposed to anonymous.
Yeah.
You can identify somebody in one transaction, you can track it all the way through.
Yep.
Just ask the people at Silk Road.
Yeah. The U.S. government actually just so there was an individual in the Silk Road lawsuit that finally gave up his private keys, and the U.S. government just moved 69,000 Bitcoin. They seized it, and it was the fourth highest amount for any single address.